Okay, so here is the video for the Unit A skill cards. So this first one says simplify completely, express your answer without negative exponents. So if you see a problem like this, the first move will be to start combining like bases on the inside. Okay, so on the top, that's a to the first. So I've got a to the negative 2, b to the second, c to the seventh on the top. On the bottom, I have a to the fourth, b to the sixth, and that's just c to the first. Okay, now I still have like bases, but they're like vertical to each other. So I'm going to subtract the bottom exponent from the top exponent. So what that's going to end up looking like is we'll have a to the negative sixth. You're doing negative 2 minus 4. And then b to the 2 minus 6. And then c to the 7 minus 1. And then that stays on the bottom. Then all of the inside exponents, you multiply by the outside exponent. So you'll have over. Okay. Then it's at this point, guys, where you could do the thing where we go, all right, well, first of all, this is 16, sorry. And then that right there, that's going to be 9. Okay, so I'm going to do actually the short move that we learned recently. So everything with a positive exponent is going to stay exactly where it's at. But if something has a negative exponent, that is going to move to the other spot, and the exponent's going to become positive. So this c to the negative 12th on top, I can make it c to the positive 12th on the bottom. And if you started with a negative exponent on the bottom, it would move to the top, so the other, other way. So we've got 16, 12, b to the 8th, all over 9, c to the 12th. Okay, so yeah, that's the answer to that first one. Okay, now the second one, it says factor completely. So when you're factoring, guys, you want to be looking for greatest common factors, often, but also you want to remember our three three factoring forms that we've been working on. So a squared minus b squared, a cubed minus b cubed, a cubed plus b cubed. So if we had either of these, you'd be using that SOAP method, where you have a little binomial and a longer trinomial, etc. What we're looking at here, guys, even though the bases are binomials, they are of this form. Okay, this is a difference of 2 squares. So what happens, guys, with the difference of 2 squares is that when you factor it, it's a plus b, a minus b. Okay, so it factors like that. So what I'm working with here, let me write the problem. I've got x plus 5 squared. Okay. So this is going to factor like the same way, except like this binomial would be a, and that binomial would be b. So let me just set it up like this. So it's going to look just like that. So we have a plus and a minus, and then a is x plus 5, and then b is 5x minus 3. Okay, now we have to simplify what is inside of the parentheses, and then we're going to get like proper binomials once we combine all the like terms. So this is all adding in here. So x plus 5x is 6x, 6x plus 2. Okay, so that's going to be that binomial. This one, I actually have to distribute the negative first, and then I can combine like terms. So that's negative 4x plus 8. Okay, So let me write it nicely, and there's a couple more moves. Let me turn over here. So we've got 6x plus 2, negative 4x plus 8? Yes. Okay. Now, if you get to this part, you did like a really good job, except it's not factored completely because from each of these binomials, you could take out a GCF. So from here, we could take out a 2. And then we have 3x plus 1. From here, we could take out a negative 4. Okay. And then, guys, the GCFs that come out, if they're coefficients, you could just multiply them. So this is 2 and times negative 4. It's negative 8. 3x plus 1, x minus 2. Okay, so there's that second problem. Now this third problem, so we get into more factoring forms. So number 3, factor completely. All right, we got that. 121 minus 64x squared. Now, guys, this is actually, we've got this form, a squared minus b squared for this one. Because, okay, what would have to go in here? What would the base be for us to end up with 121? 11. Okay, so 11 is your a. And then this one, 64x squared, what would this base have to be in order to get that? It would have to be 8x. All right, so those are your A and B. So, and most people, guys, kind of do this little, like, you know, this in their head. They just kind of can see 64 is a perfect square, 121 is a perfect square, and they know what the square root is. But as soon as you know you've got a difference of squares, it's going to factor as a plus b, a minus b. So 11 plus 8x, 11 minus 8x. Okay, so there's that one. Number 3. Okay, number 4. This is, so this one is a difference of 2 cubes. Okay, so this time we've got this form, a cubed minus b cubed. And let me figure out what the a and b are. Okay, so the a is just a lowercase a. And then this base would be 3v. Okay. So guys, once you know what your a and b are, those are the bases, then this is how it will factor. You're going to have a little binomial and then a longer trinomial. And you're going to remember SOAP for the signs. So same sign. So we originally had a minus. So minus. Opposite sign. Plus. Always positive is the last one. Okay. And now this is how the bases go in. So we're going to be putting A and 3V in to these spots. Okay, so we've got A and 3V. Then here, you're going to square the first one. Okay. At the end, you're going to square this last one. So that would be 9V squared. And then in the middle, you multiply them. So that would be 3AV. All right, so that's how that looks. All right, that's a difference of 2 cubes. The next one we've got here is a sum of 2 cubes. So we've got to figure out the bases. So we've got a cubed plus b cubed. All right, and I got to figure out what the bases are in order to get this result. Okay, so right here, the base for this would be 5t. And then there, that's just d. Okay, so now we go to the SOAP thing. Binomial, trinomial. Same, opposite, always positive. 5t, d. All right, here you square the first base, which is 25t squared. Here at the last part, you square the second base. And then in the middle, just like before, you multiply the two bases. So 5 dt, or td. Okay, sum of cubes. Alrighty, more factoring. So this next one, number 6, we've got 9x squared x plus 15 x plus 5. Okay. All right, guys, so you want to look at this as two terms. All right, so that, think of that as the first term, and then that is the second term, because they're separated. Terms are separated. Terms are anything that is like separated by pluses and minuses. So we got that minus in the middle, so those are each terms. Do they have anything in common? Yes. The binomial x plus 5. So that a binomial, guys, can be a GCF. So we're factoring out a binomial as a GCF. And then what is left inside here when we do that? 9x squared minus 16. Okay. And now you got to see if either of these, so we got two binomials here, and one of them factors further. It is this one. This one is a difference of two squares. So this just comes down, and then this is going to factor 3x plus 4, 3x minus 4. Okay, because the base here is 3x, the base here is 4. Okay, if you are squaring. Okay, great. Now this next one, number 7. So we've got 7x minus 3 minus 7x minus 3 squared. Okay. So guys, say that you're on the midterm and you're really not quite sure what to do. You could, something that always helps when you're factoring is if you see something, if you could do some kind of like a substitution off to the side that makes it look easier, like a similar but easier problem, then it could help you get started. So we've got, I see this binomial 7x minus 3, I see it twice. So how about in my head or off to the side, I just pretend instead that is a u. So what I've really got, guys, is u minus u squared. That's what we're dealing with here. Now think for a second, how would you factor this easier one? You would take out a u, and what would be left inside is 1 minus u. Guys, this is the same idea, except we're taking out an entire binomial. So 7x minus 3, and then what's left inside is going to be, similar to this. So the minus comes down here. What's left here is just a 1. What's left here is 7x minus 3. Now you've got to distribute the negative and combine like terms. So 1 minus 7x plus 3. Okay? So we've got 7x minus 3, negative 7x plus 3. Now, if you stopped here, guys, on the test, I'd give you full credit because you can't take out, the only thing you could take out from here is a 1, and here you could take out a negative 1. There's no point in just taking a 1 out. But the negative 1, people often factor that out. So here is another. So if you can remember, guys, to factor out a negative, it is helpful, like when you do harder problems in the future. So that's why my problem on the back looks like this. Wait, what happened? Oh, there's a plus 4. Sorry. 4 minus 4. Okay, so this here is my answer in the back, but this is just fine. Works also. Okay. Alrighty, moving on. All right, I'm gonna have to do this in 2 parts, guys. I'll do one more, and then another class is gonna start soon. So now we're gonna factor this one. So I've got x minus 2, 5x minus 6. Okay. Alrighty, so I see this big plus sign in the middle. So I've got a term here and a term there. Do they have anything in common? They have a binomial in common, x minus 2. So we could take that out. Okay, now in here, I'm going to have to distribute and combine like terms. So this is just 5x minus 6 plus 3x squared. Okay, so that's what that is. X minus 2, 3x squared minus 5x plus 2. Okay, so now guys, we're not done because this trinomial will factor further. So a times c, so 3 times 2 is 6. So two numbers that multiply to make a positive 6, but add to make negative 5. Negative 2, negative 3. Okay, so now instead of a trinomial, I'm going to have 4 terms. And then I have to factor by grouping. So from here, we could take out an x. From there, I could take out a negative 1. Okay? And then I've got x minus 2, x minus 1. Okay, so there's that answer. All right, guys, so I will make a part 2 where I finish 9 through 14.